Okay, so we are in an introduction to statistical learning, chapter 4. We're in the conceptual questions, question 7. Let me just read this. Suppose we wish to predict whether a given stock will issue a dividend this year, yes or no, based on X, where X is last year's percent profit. We examined a large number of companies and discovered that the mean value of X, which again is last year's percent profit, for companies that issued a dividend was X bar equals 10, while those that did not issue a dividend had a X bar equals 0. So no percent profit. In addition, the variance of X for these two sets was 36. Finally, 80% of companies issued dividends. Assuming that X follows a normal distribution, predict the probability that a company will issue a dividend this year, given that the percent profit was 4 last year. Okay, and so it tells us that we will have to use Bayes' theorem and to remember that the distribution for a normal distribution, that the expression for it is given here. Okay, so this is pretty straightforward. So we just need to find the posterior distribution of the probability of yes, given that X equals 4, plus all the other information that we had. Okay, so you can kind of see how I did this, right? I'm just applying Bayes' formula, so I just reverse. So first I get the probability of 4 given that there was a dividend times the probability of there being a dividend divided by the probability that X equals 4, and we just expand that out. We expand that out. I won't be monotonous and just go through every step here. But eventually we plug in the values to these expressions, and we get about 75.2%, right? So the probability that this company or any company issues a dividend given a percent profit of 4 is about 75.2%. Okay. Now, and that's the end of the question. But let's keep going a little bit. So recall that LDA, linear discriminant analysis, is equal to a Bayesian classifier, which we've done here, when the data is normally distributed, which it is here, and the different categories, their data is all has the same variance, which also applies here. So this means that we should be able to apply LDA to a data set where X bar for yes is 10 and X bar for 0 equals no, or for no equals 0, right? And we should arrive at about a similar posterior probability distribution. So let's do that. Okay, so first I'm just going to generate some fake data. So I have a factor here that I'm calling dividend, or I'm going to turn it into a factor, and it's either yes or no. And so I have 80 yeses and 20 no's, right, reflecting the prior given to us, right, which was 80% of companies issue dividends. Okay, and then we have X yes. So the value of X, when it is yes, has a normal distribution of a mean 10 and standard deviation 6, right? And so if I square that, I get 36, right? And that's the variance that's given to us. And then when X or when there is no dividend, the value for X is 0. So an average of no return, or no percent profit, again with a standard deviation of 6, which is a variance of 36. And now I wrap all of that into a data frame that I'm calling D. Okay, and so D looks like this. So here's just the first few rows. So I have just yeses that are showing, but towards the bottom, in fact, I'll show you the bottom as well, just to show that it's in there. D. Okay, so I have yeses and I have some no's, and so there's 80 yeses and 20 no's, and then we see the value for X drawn from their normal distributions here. Okay, so let's run an LDA on this, and what we're going to get out of this is we'll get an estimate of the posterior. Okay, so I'm running my my LDA, so I need to import the library mass. Okay, and then I'm running LDA where I'm putting dividend against X with the data D. Okay, so okay, so let's pull this out here. Okay, so we have Okay, so let's look at this for a second. So when we're looking at this, the call of our LDA shows us the prior probabilities, right? Which is just how prevalent yeses and nos are in the data set, and we set it up to be 80 and 20, so those are the priors. And then it gives us the group means, okay? So they should be 10 and 0, but they're sampling bias, so we're about 10 and we're about 0, okay? And it also gives us these nice histograms here showing the distribution, right? So, so here's the histogram for yes, here's the histogram for no, and it seems like an x value of 4 is pretty safely within within the yes category, okay? But let's see what the R algorithm does for us and how it and where we get or where it puts our posterior probability. Okay, so so now I'm going to assign a new observation, x equals 4, and I'm going to predict that observation, right there, given the LDA we just ran. Okay, and so what do we get here? Okay, so we get that. So it's first of all, it's classifying it as yes, and it has a posterior probability of yes of being about 76.6%, which is very, very close to what we found analytically. You know, the difference is just because of the sampling bias that we introduced by randomly sampling our data. Okay, so that's it.